5, 12,856.
I've got the travel guide and the tickets for the tropical vacation. Oh, I can't wait to feel the warm sun and walk on those sandy beaches. Chris, what are you doing?
Hang on 1 second. I'm counting. I'm trying to figure out how many grains of sand there are on this beach. And I figure if I can just count the number of grains in this pile of sand and then multiply it times the number of...
Chris, you've been here since August. Just let it go. Besides, wouldn't you rather be counting tropical beach sand? It would be a lot warmer.
12,856.
But if you are investigating sand, then I've got a question. Beaches all over the world are covered with this stuff.
9, 6.
And it doesn't just grow out of the ground. So where does all the sand on the beach come from? Just imagine your favorite tropical hotspot. Crystal blue waters, lush palm trees, and an endless sandy shore. To find out where all the sand comes from, let's follow its journey from day one. It all begins here. In this world of colorful creatures lives another group that's a little harder to spot. They're known as polyps, and they live inside a stony structure called coral. Polyps are small jelly-like creatures. Because they have soft bodies, they're vulnerable to the harsh environment of the ocean. So to protect themselves, they extract calcium carbonate, a mineral found in seawater. Like tiny architects, the polyps construct coral out of calcium carbonate. This coral is really their skeleton, but unlike ours, their skeleton is found outside their bodies, so it acts like a fortress, shielding the polyps from the battering waves. When these animals die, their skeletons get pounded repeatedly by the waves. The shells of other sea animals get crushed in the same way. As they ride the surf, the coral and the shells go through a bumpy ride, bashing into each other and getting worn down in the process. Eventually making their way here, to the shore. So next time you're on a tropical beach, keep in mind that most of what you're walking on is the skeletons of millions of dead marine animals.
Hey, snap out of it. We're not in the tropics yet. And besides, there's no coral in this water. So, where did all the sand on this beach come from?
The sand on this beach has a different origin. That's why if you compare it to tropical sand, it looks very different. You see, coral reefs need the right conditions in order to grow. They need shallow, clear water with lots of sunlight, and the water has to be warm all year long. So what you see here today isn't coral, but it's the result of what happened millions of years ago. Back then, the Earth was covered in glaciers. A glacier is a moving river of ice. The force of the ice is so great that it acts like a bulldozer, ripping the rock bed and carving out large boulders. These tiny grains of sand came from a huge boulder like this. Now, you would think it would require the work of a hammer and chisel. But there's a greater power at work here, much stronger than these. It's the power of water. But how can water turn this into this? When water freezes, it expands. But when water gets trapped in a confined space, like this jar, something else happens. As the water turns to ice, it exerts a pressure so great that the jar explodes. The same thing happens when water gets trapped inside a rock. This pressure inside creates hundreds of tiny explosions that over time shatters the rock into small fragments. So now, a couple of million years later, we're left with fragments of boulders, but we're nowhere near a sandy beach. This is where the river becomes a part of the journey. The rocks hitch a ride with the river and are carried downstream. The river moves the rocks in the same way as this rock tumbler. When the rocks enter the water, they start out with rough and jagged edges. But as they get smashed around, they grind into each other, getting smoother and smaller. But the journey for the rocks isn't over yet. We've got small rocks and pebbles, but it's still not sand. Like a relay race, the river passes the rocks over to the waves of the ocean. The waves are the final carriers in this journey. Not only do they move the rocks, but they also sort them according to size. They act very much like the water in the sand, separating the pebbles from the sand. Since the pebbles are heavier, they get left behind. But the lighter grains of sand get moved further until they're deposited here, the beach. Even more sand is formed when the waves come in contact with the cliffs. The constant crashing of the waves chip away at the coast and grind the debris into more grains of sand. The force of the waves can be as strong as the impact of a car crashing into a stone wall at 140 kilometers an hour. This gradual wearing down of rocks also explains how huge pockets of sand are formed in some of the most remote regions of the world. The desert. The sea of sand comes from the weathering of desert rock. But there aren't any ocean waves here. Instead, the wind does the work. These strong desert winds pick up the sand and smash it around the surrounding area, carving the bedrock. This power works just like sandpaper, wearing away at wood.
13,421, 22.
Sorry.